Loud.
Get off my lawn!
Section 2.
This started as our news and notes, our tids and bits, our clickbait.
Yes. Glad you finally admit it.
It just wasn't happening. It just wasn't happening. So we're trying something different. This is the third week of this. We're doing Carissa Explains It All.
Yes.
So
Because Dawn has no originality, and if any of you can think of a better title, please help us out.
What do you got against the title? Anyway, so here's the phone. You're going to drive Keynote with the phone.
Driving Keynote. Okay. Well.
There you go. Swipe right. Okay.
What would you know about swiping right?
I don't know.
Okay.
I know that's a thing. Isn't it left is you don't want the...
I don't know.
Who knows?
You and I were already married when that came out.
That's true. How long have we been married? 9 years? 8 years?
8.5.
Yeah.
It'll be 9 in June.
Yeah.
So yeah, don't ask me left or right. I have no idea.
Fair enough. Yeah, I don't know. I think it's right. I have single friends, but I haven't been single in a long time. Yeah. Because we didn't exactly, meet and get married. We dated for a while, and then we were engaged for a long time, and then, yeah. That's how you do it.
And that's why it cracks me up whenever your single friends come to town and want you to take them out to meet women.
Yeah,
so I'm you have no clue. You've been with me the entire time we've lived here.
Admittedly, I'm more in touch with that particular segment of society because of Teen Mom. So watch for the hat if you watch Teen Mom.
Yes.
And the shades. Well, not these shades. We left the Ray-Bans downstairs.
Yes.
Yeah, these were given to me a long time ago. So relativity.
Okay, relativity. So there's 2 parts to relativity.
Well, what is relativity? That's the Albert Einstein E = mc squared?
Well, that's why it's more confusing than that. They're both Einstein.
Okay.
But it's basically 2 parts. There's special relativity, which applies to elementary particles.
Slow down and talk to the audience. Special relativity. It applies to elementary particles and their interactions, describing all their physical phenomena except gravity. Really, we have a hard stop at 6:30. We have 55 minutes left.
Okay.
We'll be fine.
Okay. So there's special relativity, and then there's general relativity, which explains the law of gravitation and its relation to other forces of nature.
Right.
So,
I don't get it.
Very young Einstein. So special relativity came first.
Don't mind me. I'm just making sci-fi noises.
You're going to get something thrown at your head.
Yeah, I know. Keep going.
Okay. So it was originally proposed in 1905 by Albert Einstein in the paper on the electrodynamics of moving bodies. It's based on 2 postulates. 1, the laws of physics are identical in all inertial systems. And then 2, the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source.
So, what? I was playing with my theremin. Did you guys understand that? Leave me a comment below. All right.
Okay. 1, the laws of physics do not change.
Yeah, okay.
2, the speed of light is always the speed of light in a vacuum.
Fair enough.
Okay? Doesn't matter where you are or if the light source is moving, it's always the same.
But those 2 things could, in theory, be wrong. Because these are the constants, right? These are the things that are required to be true in order for all this to work.
Yeah.
We're living in a simulation. Keep going.
Okay, so the consequences of special relativity. So the first one is relativity of simultaneity. 2 events, simultaneous to one another, may not be simultaneous for another observer if the observers are in relative motion. So,
What? Okay, listen. You're going to teach high school kids.
Okay, so you've got observer A and observer B.
Okay.
Now the colored lines, the green, the red, and the blue.
I thought we said we were... Okay, keep going. Could do dashes and dots.
No, I couldn't have. So those all occur at the same time. They're all simultaneous.
Okay.
But based on the position of the observers, only the green appears to be simultaneous to both of them at the same time. It only appears to occur to both of them at the same time. The others do not.
I'm going back to playing with my theorem. Keep going.
Okay. So then, second one is time dilation. So moving clocks are measured to move more slowly than an observer's stationary clock.
Yeah, I knew that.
So astronauts age more slowly in space.
Right, and if you take a watch out, and really even if you take a watch up on an airplane, if you fly long enough, your watch will be off.
Yes.
Even if it's a digital watch.
Yes.
Yeah, keep going.
Okay. So then you got length contraction, in which objects are measured to be shortened in the direction that they are moving with respect to the observer.
Less words, more pictures. Keep going.
Then the mass energy equivalence, which is the E equal mc squared, which is what we talked about last week. Maximum speed is finite. No physical object, message, or field line can travel faster than the speed of light in a vacuum. So speed of light in the vacuum is pretty much the limit of how fast anything can move.
Though haven't they been able to get things to move a little faster than the speed of light? Keep going.
Yeah, that one's still a little up in the air. That one might be changing at some point. And then the effective gravity can only travel through space at the speed of light, not faster or instantaneously.
Fair enough. Yep.
Okay. So that's special relativity.
So like if mass appeared out of nowhere, it would take the speed of light to even start affecting its other things around it.
Yes.
Yeah.
Okay, so then general relativity was the theory of gravitation developed by Einstein between 1907 and 1915.
Wasn't that his sister?
What?
I'm pretty sure there's been a thing over the years that Albert Einstein actually, that his sister did a lot of the research.
Okay, I found nothing on that.
Really?
Yeah.
Leave a comment below. Let's point it out. All right, keep
Are
going.
you starting a conspiracy theory?
No.
Okay.
I read this somewhere. I mean, it might have been InfoWars. I don't know. Keep going.
Breitbart is not a real news source, dear.
I don't read Breitbart.
So general relativity begins with the equivalence principle. The state of accelerated motion and being at rest in a gravitational field are physically identical. Then you've got the free fall and inertial motion, in which an object is falling because that's how objects move when no force is exerted on them instead of being due to gravity. You look so confused. Okay.
I'm pretty confused.
Okay. So that last one, the free fall, is incompatible with classical mechanics and special relativity. So inertially moving objects cannot accelerate with respect to one another, but objects in free fall do.
Okay, we're going to teach you Final Cut or something. You're going to have to, visualize this stuff.
Well, keep in mind that these particular two subjects are usually taught as a full semester class at college.
Keep going.
So I'm trying to condense them, okay?
All right. I'm just going to accept that what you're saying is always true.
Okay.
For once.
Mm-hmm. That'll be a first.
Yep.
To resolve this, Einstein proposed that space-time is curved.
It's curved.
It's curved. And he explains this with the Einstein field equations, which relate the curvature of space-time with mass, energy, and any momentum with it. Now, just explaining the field equations would easily take at least an hour. So we're not going to cover those because, math.
I swear next time I'll actually record the theremin. I'm relying on the microphones. I don't know how well that's picking up. I might have to turn this up. Keep going.
Okay, so consequences of general relativity. First one is gravitational time dilation. Clocks run slower in deeper gravitational wells. So,
is that why you perceive yourself as accelerating as you enter a black hole? Or as you fall?
Not quite. Okay. Think of space-time like a trampoline.
Okay.
And then...
But a trampoline is two-dimensional. See, keep going. We don't want to say...
Think of space-time as a trampoline, the surface of a trampoline.
Okay.
Then, the Earth or the sun or whatever.
You have it visualized here on screen.
Right. Is basically a bowling ball.
Okay.
Now, this visual comes in handy for the rest of this as well. So, how the trampoline bends is the curvature of space-time.
Okay.
Due to mass. Okay?
Sure.
So then, orbits precess in a way unexpected by Newton's theory of gravity, which precession is the way, like, a planet rotates on its axis, and, like, how the axis tilts. So, they're actually noticing this with Mercury.
Okay.
And there's been some very subtle changes over time that are explained by general relativity.
Yes.
Yes, hi, Pumpkin.
He's Studio Cat.
Yeah.
Hashtag Studio Cat.
Hashtag Studio Cat.
And we had hashtag Regal Cat earlier.
Yeah, she's still here.
She is.
Okay, so this is that. Then rays of light bend in the presence of a gravitational field.
Yeah.
So that's gravitational lensing, which we've talked about the last 2 weeks.
Which you can totally do in your home.
Sure.
You can make light bend in your house.
Mm-hmm.
You take a piece of paper, take a thick cardstock, you cut a slit, very thin slit, run light through it. I think if you put 2 of them, it'll do all sorts of patterns and stuff. Very neat.
I was thinking more of Einstein's cross, which it's a quasar on the other side of a galaxy. And so the way the light bends, you actually see 4 quasars instead of 1 around this galaxy.
Yeah, I want to be able to let people try this at home. All right.
Okay. So we'll keep moving.
So we know the universe is expanding at an accelerating rate.
Yes.
Which makes no sense. We talked about that last time.
More math.
Yeah.
A lot more math. And rotating masses drag along the space-time around them, which is called frame dragging. So they've actually proven this one with Gravity Probe B, which they put into space in 2004.
Yeah.
And were able to actually test this and confirm it. So...
Your microphone is super hot for some reason.
Why is my microphone super hot? What'd you do?
I don't know.
What'd you do?
I didn't do anything.
Okay. And so, yeah, that is relativity in a nutshell. Which,
So
like I said, it's usually like a semester-long class. So.
But that doesn't explain how mass and energy change into each other.
I've explained that before.
Okay. What's next?